Hi everyone, welcome to this video. Give me a second, let me just adjust this. Okay, great. We are looking at question number 3 of the, let's make a couple of notes. FAMS, yeah? Sample questions from the SOA website. You can look up the question yourself. There is also a solutions page. You can look it up. This is question number 3. A pretty straightforward question. Let's just talk through it. It says the distribution of accidents, right, for 84 randomly selected policies is as follows. Number of accidents goes from 0, 1, 2, right up to 6. And number of policies, we have all those numbers there, and we've got a total of 84. And we asked, determine which of the following models best represents this data. Okay, so they've given us some choices, the negative binomial A, and then B, we have discrete uniform, and C, we have got Poisson, D, we have binomial, and E, we have zero modified Poisson. Okay, so a couple of ways to deal with this problem. Let me just look at the solution I've written first, go through that, and then maybe give you some ideas on how to look at it in an alternative way. Okay, so I'm going to do it this way. I'm going to look at an estimated mean, and I'm going to look at an estimated variance. You got that? I'm going to look at I'm going to work out a value for the estimated mean. Then I'm going to work out a value for the estimated variance, and then make a comparison, and then draw my conclusion. Okay, pretty straightforward. I repeat, you also have a solution to this question on the SOA website. Please look at it and see what they have presented. Okay, so let's start slowly, right? Let me just go ahead and estimate the mean. Let me see. Okay, so in our statistics class previously, we would have learned this. Remember when we studied group data, right? We have studied this, right? So that's basically what I'm going to do. So to get this out, I'll just take, or maybe I should just look at my solution, right? And then you can follow along. Okay, just follow along. There you go. Yep. Okay. So let me just get rid of that. And just since I have it all on the screen, might as well talk about that, right? We don't want to reinvent the wheel. Okay. So there you go. We have, I'm trying to find the estimated mean, or rather I'm trying to estimate the mean. All you have to do is just take all the values. We have got 0 multiplied by 32. You don't have to write down the exam. 1 times 26 plus, what do you call it? 2 times 12, and so on, right? All the way up to 6 times 1, which is what you'll see here. Just before that, you'll see a 5 times 2, and so on. So plug all those numbers in. Very easy to do, right? And then you divide it by the total, which is how much? 84, and you get a number 1.22619. Okay, I'm sorry about this writing, right? It appears a little bit on the lighter side. I think it's the pen that I used. I apologize for that. I'll change that the next time around. Okay, 1.22619. That's my mean, right? I'm estimating the mean. Now I'm going to go ahead and estimate my variance. So I have written down this formula here. This one here is the idea that I want you to run with, right? This is the idea. This is not a formula I'm going to use. This is the idea. I'm trying to work out the variance. So you will see this formula. You would have seen this where? You would have seen this in your high school days. 1 over n, and then in brackets, your summation x squared. Then you've got minus summation x whole thing squared over n. Now, this formula is for ungrouped data. But remember what I said? It's the idea we want, right? So in our case here, we are going to use this one here. Okay? So first you have to go and work out your x squared f over n. Let me write that again, right? S squared will be, in case it's not clear, right, minus your x bar squared. This one, nothing to worry. We already have that value, which is 1.22619. We need to work this out, right? So all you have to do is just take what? Take, let me write it here. Let me find some real estate, right? Okay. Okay. So now we are okay. So I'll start with 0 times 32 plus 1 times 26 plus 4 times 12. Get it? Yeah, because remember, this is now x squared, right? If this is an estimate, basically, right? This is an estimate. Remember from our stats class, right? This is basically an estimate of your second moments. I don't want to use those words because, simply because of the fact we're dealing with a sample of data and so on. So the idea is the same, right? We're trying to get the second moments minus the first moment squared, right? To get a variance. So I have x squared here. So you have got 2 squared times 12, and then I have 3 squared, 9 times 7. So go ahead and do that. Okay, and final number will be what? This will be 6 squared times 1. So use a calculator, and your numerator works out. You can work it out on your calculator. This is the numerator, and don't forget to divide by your total number of values, which is 84, right? Okay, your you have a total of 84. So plug all these numbers in the numerator, divided by 84 minus your mean squared, and you'll get 1.9131. Okay, let me move the screen up. You'll get your variance as 1.9131. You will see that here. Okay, great. So now we can clear this thing. Good. Okay, so your X bar is 1 point, let me just write down 226, right? And then my S squared is 1.913. So you can see that your variance is bigger than your mean. Therefore, we know it'll be a negative binomial distribution. Okay, negative binomial distribution, which is A. Okay, I've written all the facts down here. That's all there is to it, to this problem, right? This is an extremely simple problem. The alternative, right? But look, once you see that your variance here is bigger than your mean, we draw a conclusion it's a negative binomial model. We don't have to worry about the Poisson. We don't have to worry about the zero modified Poisson. We don't have to worry about the binomial because the binomial is just the reverse, right? Okay, your variance will be less than your mean. Okay, and we don't have to worry about discrete uniform, which is the easiest thing to throw out in this particular problem, right? So we're done. Negative binomial. The other thing that I want to let you know before I close the video is, let me just get rid of this, a couple of remarks, yeah? Okay, a couple of remarks. What you can do, it's in our textbook, so I'll just tell you about it. Remember, we have ABO, right? Class of distributions, and we had this thing here, PK over PK minus 1. Remember this? Okay, let me write a few things down for you guys, right? PK over PK minus 1 will be, let me write it here, A plus B over K. Remember this? This is for our ABO class of distributions, right? PK over PK minus 1 is equal to A plus BK. What you can do, right? You can multiply throughout by K. If you multiply throughout by K, you'll get K, PK over PK minus 1 will be equals to AK plus B. Okay, so this one technique that is used in our book. So I thought I'll tell you about it. Look, this should remind you of a straight line, MX plus C, right? So what do? You need to plot, right? You don't actually have to plot, right? Once you get the numbers in the form of a table, you can see the slope appear, the slope staring back at you, so you can draw your conclusions. Okay, so technically, we have to go ahead and draw a curve, right? This thing here, plot this against this, right? Now this one here, you can go ahead and estimate it, right? You can estimate it using n over nk minus 1. These things are all given in our books, yeah? So you don't have to worry about anything. I will tell you again, right? This thing, you can estimate it using our observations. So you plot this against k, and you get a straight line, you're dealing with a, you're dealing with a ABO class, right? Dealing with the ABO class of distribution. So if you have a positive slope, then you're dealing with a, so This one you plot against K, right? This versus K. And if you get a positive slope, you're dealing with your negative binomial distribution. Okay, that's it. We don't really actually have to draw the line. This is a multiple choice test, right? So you can go ahead and set up a table. What are my values? Let me look at the values again. Okay, in our case, right? In this case, we have got 0, 32. You can look at the question again, right? 1, 26, and all that. So you can go ahead and set up a table, right? So not so bad. This is 2 and 12 and so on. So you're going to get values like, 26 over 32. And then you're going to get values like 2 times 12. What's the value before that? 26. So you set up a set of values like this in form of table. You will see, right? We are dealing with a positive slope case. Therefore, you know you're dealing with a negative binomial distribution. Okay. So, but I chose to do it using just variances and means, and we are done. Okay. Thank you very much for watching.